Hello, in this video we're going to learn about function rules. Here's some important vocabulary that you'll need to pay attention to during the course of the lesson. Domain, range, values of a function, and function notation. So the first thing we're going to do is use function tables, which you'll remember from earlier in the chapter. So if I want to figure out some values for y when x is -2, 1, and 5, I can just make a little function table and then plug the values into the function. So I can say, I'm just going to write -6 here in one color so I can use a different color to plug in. So here x is -2, here x is 1, and here x is 5. So I made this function table. You can see it's -6 times whatever x is at the time minus 5. And so when x is -2, we do -6 times -2 is 12. Subtract 5 and we get 7. When x is 1, it's -6 times 1 minus 5. We get -11. And when x is 5, we get -30 minus 5, which is -35. So the values of the function are all the y values. So we would consider these, circle them here, these would be the values of the function. Okay. Now we would call all possible values of x, we would call that the domain. So we could say that this is the domain. Then we would call all possible values of y, or the values of the function, we call that the range. Okay. Now in strictly mathematical problems like an equation, the domain can be anything. And the range can be anything, because you could plug in any value for x. You could plug in 2 or -5 or 1,000,000 or something like that, and everything works. However, when you get to a real world problem, like if you were wondering how many calories you get from eating a, however many In-N-Out burgers, the domain would only be positive numbers, right? Because you can't eat negative burgers. And the range would only be positive amounts of calories, because you're not going to get negative calories from eating burgers. But strictly from an equation point of view, the domain and range could normally be anything. But what you have to remember is the domain is the x values and the range is all the y values. All right, let's do this green one here. Y equals x squared plus 1. So we're going to square whatever the x value is, and then we're going to add 1. So let me write that in green. Okay, and the x values I'll put in black again. So we have -2 squared, 1 squared, and 5 squared. So when we square -2, we get 4 plus 1 is 5, 1 plus 1 is 2, 25 plus 1 is 26. So the values of the function are the y values, the 5, the 2, the 26. The domain is -2, 1, and 5. So we'd say we call this the domain. The range, R, is 5, 2, and 26. In this case, I'm going to erase these to make room for something. Okay, so now we need to talk about function notation. Function notation is a different way of writing the equation. And it's going to look funny, but you'll see that it's exactly the same thing. So if I write f parentheses x equals -6x minus 5, this doesn't mean f times x, because if we were multiplying two letters together, we wouldn't need the parentheses. This is actually read as f of x equals -6x minus 5. Or the value of f at x is -6x minus 5. So f of x really means the value of the function. And if I was going to put this equation in function notation, it's the exact same thing, except I replace the y with f of x. Alright, Alright, let's go to this. So notice on the left side I've shown you the instructions for the previous page, and I've shown you what I wrote for the previous page. In function notation, it would look almost exactly the same. The equation would look like this, and the instructions would look like this. So instead of saying find values of each function, use -2, 1, and 5, with function notation you can just say find f of -2, and what that means is find the value of the function when x is -2. Find the value of the function when x is 1. Find the value of the function when x is 5. So it's a shorthand way of doing it, and actually works out nice and quick. So the same thing would happen given these instructions. I need to find the value of this function at these three x values, or these three x coordinates. So I would just make my table same as before. Instead of writing y, I would write f of x, still plugging in -2, 1, and 5, and still doing the same thing to get my answer, plugging in -2, subtracting 5, getting 7, plugging in 1, subtracting 5, getting -11, plugging in 5, getting -35. Everything else remains the same, except this is just function notation. And it's just easy to do it shorthand like this to explain what's going on.